Hey everyone, I'm Gordon.
In this tutorial, I'll show you how I textured this Chinese red envelope entirely inside Blender using Ucupaint. We'll start by unwrapping the UVs and then optimize them. Next, we'll set up Ucupaint and create the base red paper material. Then we'll paint the creases and emboss details and use stencils and decals to create the decorative patterns. After that, we'll create and blend the embossed gold foil before adding edgeware and dirt, along with other surface imperfections. Finally, I'll show you how to export the finished texture maps.
This tutorial is very step-by-step, so I'll cover the entire process from UV unwrapping to exporting the finished textures. If you're already comfortable with Blender, you can skip straight to the Ucupaint section using the chapters below. Let's get started.
Let's start with UV unwrapping the model. UV unwrapping is the process of unfolding a 3D model into a flat 2D layout so it can be textured. Go to the UV editing workspace. Press period on the numpad to zoom in on the selection. Switch to object mode and select the object. To the left, we can see the faces of the object unwrapped onto a UV map. Right now, they're overlapping each other. In order for each side of the object to lay flat on a texture map, it needs to be unfolded. However, you can't unfold something that is not split. So to split and unfold it, we need to mark seams. It'll be easier to select edges if I open the model first. This setup is specific to my model and rig, but I'll quickly show the process behind it. I'll select the rig and switch to pose mode. Then I'll use the action controls to unfold it. But if we switch to mesh edit mode, it snaps back to its folded state. To prevent this, go to modifier properties, then enable the edit mode and on cage toggles on the armature modifier. This allows the armature deformation to remain visible while editing the mesh. Now we can see the transforms of the armature being applied in edit mode. I'll also tilt the notch a bit so its edges are easier to select. This can help when selecting seams around tight or overlapping areas. Switch back to mesh edit mode, then I'll hide the armature so we can see better. Next, press 2 to switch to edge select mode and let's start marking seams. If you don't know where to start, a good first step is to mark seams at sharp edges. Go to select and then click sharp edges. This selects all edges of the model where the surface angle changes. In the pop-up menu, you can see that it is set to select edges with an angle change of 30 degrees or more. Although the object is unfolded, sharpness is still calculated from the rest pose. The front and back are flat continuous surfaces, so they can unwrap as single islands. Seams along the curved deformation are unnecessary. We only need seams where the surface changes direction between the front and back. So I'll increase the sharpness angle until only those edges are selected. 70 degrees seems to be enough in this case. With those edges selected, press U to open the UV mapping menu, then click Mark Seam. Now we can unwrap the UVs for the first time. Press A to select all faces, then press U to open the UV mapping menu again. There are a couple of different unwrapping options. Angle-based looks at the angles between faces to unfold the mesh with less stretching and distortion. It usually gives a good 2D representation of the surface and is what we'll be using in this tutorial. After we click it, the parts separated by seams get unfolded into UV islands. There are two main ways to evaluate the quality of an unwrap. First, go to Overlays in the UV editor and enable Display Stretch. This visualizes how much the UVs are stretched compared to the 3D mesh. The colors gradually change from blue, cyan, green, yellow, orange, red. Blue and cyan mean little or no stretching. Green and yellow indicate moderate stretching. And orange and red indicate strong stretching. Our UV map is mostly dark blue, which means there is very little stretching. Zooming in, there are also some cyan and green areas. To quickly find those areas on the 3D model, enable UV Sync selection. Now the selection in the UV editor is synced with the 3D viewport. Select an area in the UV editor and press period on the numpad to zoom in on it in the 3D viewport. Parts of the model start to disappear when I zoom in. To fix that, go to the View tab in the M panel and lower the clip start value. The stretching mainly appears around the intersections between the flaps, but if I disable the edit mode and on cage toggles, the UVs become blue again. That's because the UVs were created from the folded rest pose shape. The stretching only appears once the mesh deforms. Blender measures UV stretch based on the distance between vertices. When the object unfolds, the vertex distances change in 3D space, but the UV coordinates stay the same. However, the surface is only bending, not stretching like rubber. The texture bends together with the mesh, which is exactly what we want for paper. So some stretching during deformation is expected and usually not a problem, especially in areas where the mesh bends or changes direction. The second way to evaluate UV quality is to use a UV grid texture. Go to the material properties and add a new material. Click the yellow dot next to base color and choose image texture, then click new. I'll call it UV grid and set the texture resolution to 4K. 2K is usually enough for most assets, but since I don't need to optimize for performance here, I'll use 4K for the highest quality. We can disable alpha since we don't need transparency information for this texture. Then change the generated type to UV grid and click new image. Now the material has this grid image connected to the base color. You can view it on the model by switching to Material Preview or Rendered Preview. This helps visualize stretching directly on the 3D surface rather than only in the UV editor. For example, the squares along the creases where the mesh bends are slightly stretched. It also helps visualize something called Texel density. For example, I'll mark seams around the notch, unwrap it again, then hover over the notch island and press L to select it. If I scale the island up, the checker pattern becomes smaller. This means the texel density increases, so the textures appear sharper in that area. Sometimes you may want higher texel density in important areas, such as a character's face. But for a continuous flat surface like this, I want consistent texel density across the entire area. There's another thing I want to point out. The texture stretches at the seams underneath and to the sides of the notch. Normally, stretching happens when UVs try to flatten curved geometry, but in this case, the stretching is mainly caused by the subdivision surface modifier. Subdivision smooths the mesh, while the UVs are still based on the original low-poly geometry. This can introduce small texture distortions along curved edges. If I disable the subdivision surface modifier, you can see that the stretching disappears. To keep the modifier enabled while avoiding this distortion, open Advanced and find UV Smooth. Right now it's set to Keep Boundaries, which preserves the overall UV island shape. However, some UV vertices can still slide along the edges. Switching it to Keep Corners also locks sharp UV angles, which removes the stretching. If we zoom in on other sharp corners and edges, you can see that this also fixes the stretching there. There are also other UV smooth modes you can experiment with depending on the model, but Keep Corners works well in this case. Next, let's think about the seam placement a bit more. If we zoom in on the notch again, we can see that the seam causes the texture to break. This is one reason we usually try to avoid seams in highly visible areas, especially when the surface is meant to have one continuous texture. So let's remove the seams from this area. To speed up the process, go to the Options drop-down and enable Live Unwrap. Now the UVs update automatically whenever seams are added or removed. To remove seams, select the edges, press U, and click Clear Seam. But some stretching appears around the notch once the geometry is reconnected. This happens because the notch creates a hole in the mesh. The flaps still unwrap flat even though they are curved in the rest pose. But around holes, Blender tries to smooth the UVs to avoid overlaps. If we select everything and unwrap again, there is an option called Fill Holes in the pop-up menu. If we disable this option, Blender treats the hole borders as proper boundaries. This allows the surrounding faces to relax more independently, which removes the distortion. Next, we need to decide what other seams to add or remove. For example, we could remove the seams on one side. This unfolds the UVs more like a book. I'll rotate the UVs by -90 degrees so that we can see the layout more clearly. Now the front and back are connected as one large island. This keeps the UVs aligned and allows the texture to wrap continuously across the surface. This can be useful for continuous patterns such as this brick material. The pattern lines up correctly and only breaks where the seams are placed along the outer edges. However, this also creates a lot of wasted UV space. And with an island this large, there are fewer ways to efficiently pack it into the texture area. So in this case, I'll undo and go back to the previous seam layout. I want to split the UVs further so they can take up more space on the UV map. I'll hold Shift-Alt and select the edge loops between the main body and the flaps. Then press U and choose Mark Seam. Now we have more UV islands, which makes it easier to pack them efficiently and use more of the texture space. But as you might have noticed, the texture now breaks at the seams. As we saw earlier, this makes pattern textures much harder to align, especially textures with obvious directional detail such as bricks. On the other hand, noisy textures with less visible patterns usually hide seams much better, especially from a distance. Procedural textures that use object space instead of UV space also avoid this issue entirely. You can watch my video on generated UV and object mapping if you want to learn more. So when placing seams, it's important to think ahead about how the model will actually be textured. For the materials I'll use later, these seams won't really be a problem. But it's still good practice to keep seams to a minimum whenever possible. So I'll go around and remove some of the more unnecessary ones. The edge loops I marked around the sides also cross the seams along the outer edges. This splits the corner faces into separate islands, which is unnecessary. So I'll select the edges that cross the thickness of the object. Then press U and choose Clear Seam. This reconnects those faces to the neighboring islands instead of keeping them separated. Next, even though we won't unwrap the front and back together, we can still extend one side slightly. I'll go to Back View and select the edges at the far ends on both sides. Then Clear Seams. These faces take up very little UV space and can easily be packed together with the back island. I'm choosing the back because these edges are more visible when the object is folded. The faces inside the notch also form one continuous loop, similar to the inside of a cylinder. However, they are currently separated into two islands. So I can enable X-ray, select one of the seams separating them, and clear it. This unwraps the inside as one continuous island instead. The next step is to pack the UV islands more efficiently. First press A to select everything, then go to UV and click Average Island Scale. This ensures all UV islands maintain a consistent Texel density. Next, go to UV again and click Pack Islands. The default settings work fine, but I'll increase the margin slightly. Margin is the spacing between UV islands. A value around 0.008 usually helps prevent texture bleeding. This prevents pixels from one island bleeding into neighboring islands. Then click Pack. Now you can see that we're using much more of the texture space than before. You can continue experimenting with different seam placements and unwraps, but this result is good enough for me. The last thing I want to do is straighten some of these small curved islands. You can select part of an island and press Ctrl L to select the linked geometry. Then move the islands to the side temporarily. Straightening UVs can make them easier to pack and helps keep textures cleaner and less distorted. Since each island is only a single row of faces, this is very easy to do here. First, press 2 to switch to Edge Select mode and set the pivot point to Individual Origins. Find one face on a curved island that is already relatively straight. Select the horizontal edges and press SY0. Then select the vertical edges and press SX0. Once the face is perfectly straight, press 3 for Face Select mode and select it. Then press Ctrl L to select the full island. Finally, right-click and choose Follow Active Quads. This straightens the rest of the island based on the active face. I'll repeat the same process for the remaining islands. Straightening islands can slightly affect their scale, which also changes Texel density. So once all the islands are straightened, press A to select everything. Then run Average Island Scale again to keep the Texel density consistent. Finally, with everything still selected, run Pack Islands again. After straightening the curved islands, the UVs take up slightly more texture space. It's completely fine to leave the layout like this, but you can also rearrange the islands to make the UV layout more organized and easier to read. For example, I like placing similar islands close to each other. I'll move the smaller islands out of the way again. Then I'll place these larger islands next to their matching shapes on the opposite side. To arrange them more quickly, go to UV and click Arrange Align Islands. In the pop-up, I'll set the axis to X and use a margin of 0.008. The remaining islands can also be rotated horizontally. Then run Arrange Align Islands again and set the axis to Y. Now it becomes easier to place them into the remaining empty space. The last island doesn't quite fit horizontally, but I'll move it upward slightly to keep the smaller islands grouped together. Finally, I'll change the pivot point back to bounding box center, then rotate the notch islands so the top parts point inward. Alright, this looks good enough for me, so the UV unwrapping is complete. Next, let's move on to texturing it with Ucupaint. First, let's switch to the Texture Paint workspace. The different workspaces in Blender are designed for different tasks, so it's useful to take advantage of them. This workspace has an image editor on the left and the 3D viewport on the right. The image editor can be set to View, Paint, or Mask mode. I'll leave it on View for now. The 3D viewport is already set to Texture Paint mode. Switch to Object mode and zoom in on the model. In this tutorial, we'll use an add-on called Ucupaint. Go to Extensions and install Ucupaint. I already have it installed. Don't forget to save your preferences afterward. Once installed, you can find the Ucupaint tab in the M panel. Open the Material drop-down. Here you can see the UV grid material that I forgot to rename before. You can delete it if you want, but I'll rename it to UV grid and keep it in case I need it later. Click the plus icon to add a new material slot, then click New. I'll name this material Hongbao Embossed Paper. Next, click Quick Ucupaint Node Setup. First, you can choose the name of the node tree that Ucupaint will create in the shader editor. I'll leave it as the default. Then choose the material type. You can select a principled, diffuse, or emission shader. I'll leave it on principled. Next, choose which channels to include. Color, metallic, roughness, and normal are the most commonly used channels and are enabled by default. Leave alpha and ambient occlusion disabled unless you specifically need them. Leave use linear color blending enabled so the layers blend correctly in Blender's linear workflow. Enable switch to material view so Blender automatically switches to material preview after pressing OK. Then press OK. Right now the object is still using the UV grid material. Switch to edit mode, press A to select everything, then assign the new material. Now open a new window with the shader editor. We now have a material containing a principled shader and a Ucupaint node tree. This node is connected to the base color, metallic, roughness, and normal sockets. And those are the same channels you can see in the Ucupaint interface. Select the node tree and press Tab to enter it. Everything created in Ucupaint will be stored inside this node tree. As the warning mentions, you should not edit anything here manually. Ucupaint creates and manages these nodes automatically. I mainly just wanted to show you where everything is located. Press Tab again to exit the node tree. So instead of working directly in the shader editor, we'll mainly work through the Ucupaint interface. Instead of nodes, Ucupaint uses a layer system similar to Photoshop or Substance Painter. The node setup is still being created in the background automatically. This makes it much easier to build and edit materials step by step. Layers are evaluated from bottom to top, with each layer stacking its effect onto layers below it. The combined result of all layers is displayed in the Channels window. At any time, you can preview an individual channel by selecting it and enabling preview mode. Right now we haven't added any layers yet, so the channels are still blank. Press the plus icon next to the Layers window to add a new layer. The two main layer types we'll be working with are image layers and solid color layers. I'll add one of each so we can compare them. For the image layer, I'll choose a texture resolution. In this tutorial, I'll be working with 4K texture maps. Then I'll rename it to image layer for clarity. The solid color layer does not include these texture settings. The main difference is that an image layer creates an actual image texture, while a solid color layer only stores color values directly inside the node setup. First, I'll hide the solid color layer by clicking the eye icon, then select the image layer. Switch to Texture Paint mode. I have an add-on that lets me switch modes by pressing Tab. You can also press Ctrl Tab to open a similar mode pie menu or switch modes from the menu in the top left. My current brush is set to Paint Hard. You can set both the primary and secondary color. Click and drag to paint using the primary color. Hold Ctrl to paint using the secondary color. You can also press X to swap between them. Resize the brush by pressing F, and adjust the brush strength with Shift F. These controls are also available in the toolbar at the top. An image layer starts with a transparent background. The color we currently see on the model is coming from the base color of the principled BSDF. If I paint on the model, the painted colors are layered on top of that base color and stored inside the image texture. Next, I'll unhide the solid color layer. When I do this, the strokes from the image layer disappear. This is because a solid color layer does not use a transparent image texture. Instead, it applies a uniform value across the entire model. And as I mentioned earlier, layers are evaluated from bottom to top. So the solid color layer covers the image layer beneath it. It also covers the base color of the principled BSDF. Most of the time, we only want material properties to affect specific areas, but since a solid color layer does not contain an image texture, trying to paint directly onto it gives a warning. That's why solid color layers are usually combined with masks. To add a new mask, click the plus icon in the mask section, then choose New Image Mask. The two main settings are the texture resolution and the starting mask color. For the mask color, you can choose between a fully white or fully black mask. In Blender, white means visible and black means transparent. If you start with a white mask, the material properties begin fully visible across the model. Then you can paint with black to hide areas and reveal the layer underneath. Or paint with white to restore those areas and make the active layer visible again. I'll remove the mask for now by clicking the cog icon and choosing Remove Mask. If you instead start with a black mask, all material properties begin fully hidden. Then you can paint with white to reveal them, or black to hide them again. So these are the two main masking workflows. Image layers are mainly useful when we need painted detail, texture variation, or unique information. Solid color layers are better for uniform values, usually controlled through masks. Finally, both image and solid color layers allow you to enable additional material channels. By default, all channels use the layer color as their source. For a solid color layer, this comes directly from the color picker. For example, if I set the color to white and enable metallic, the surface becomes fully metallic. Black, on the other hand, means non-metallic. For roughness, black is smooth and reflective, while white is rough and matte. For bump, white pushes the surface outward, and black pushes it inward. Image layers work the same way, but instead of using one uniform value, they allow different values to exist across different parts of the texture. So instead of one consistent metallic or roughness value, you can paint variation directly onto the surface. If you're still confused about how these material properties work together, I recommend watching my short video about PBR materials first. So when using layer color as the source, the material properties are driven by the brightness of the color values. However, you don't have to use color as the source. If you switch the source from layer color to custom value, you can control the material property using a single uniform value instead. This lets you control the entire layer independently from the painted color information. For example, all strokes can share the same metallic or roughness value. You can also change the channel source to use custom data, such as image textures or procedural textures. We'll explore that more later in the tutorial. Finally, because image layers use transparency, painting with color does not erase strokes. Instead, use the Erase Alpha brush or eraser tool. Now that we've covered the basics, let's start texturing the object. I'll delete these example layers by selecting them and pressing the minus icon. I'll also re-enable the subdivision surface modifier that I disabled earlier. This ensures the textures are applied to the final smoothed surface. Before we start texturing, I'll organize the textures and colors I prepared earlier so they're easier to access. I've stored all the textures inside a separate folder within my project folder. You can access them in Blender by switching the shader editor to the file browser, then navigate to your texture folder. Press T to hide the sidebar, and switch the display mode to thumbnails if you prefer. Next, I've prepared several colors that I'll use throughout the texture painting process. I wrote down the hex codes for 3 shades of red and 3 shades of gold. Instead of copying and pasting them every time, I'll create a color palette directly inside Blender. In texture paint mode, go to the tool settings and find color palette underneath the color picker. Click new and give the palette a name. I'll call mine Hongbao Palette. Next, copy the first hex code into the color picker. Then press the plus icon to add it to the palette. I'll repeat the same process for the remaining colors. I'll also add pure black and pure white. Now whenever I'm texture painting, I can quickly reuse or sample colors directly from the palette. That's it! Now I have everything prepared to start texturing the Hongbao. First, I'm going to create a base paper material. Instead of building the paper material completely from scratch, I've downloaded some texture maps. Inside my paper folder, I have a set of paper textures from Ambient CG. There's a quick way to load textures into Ucupaint. You can right-click an image, go to Ucupaint, and choose Open Image as Layer. However, I want to load all the paper textures into a single layer at once. To do that, press the plus icon next to the Layers window. Then choose Open Images to Single Layer. Navigate to your texture maps, select them, and click Open. Now all the textures are loaded into one layer automatically. You can click the channel icons to switch between them and display them in the image editor. All the textures share the same vector coordinates and can be transformed together, similar to using a mapping node. The color, roughness, and normal channels are already enabled, with the image textures assigned as their source. You can use Preview mode to preview individual channels directly on the model. Finally, to keep things organized, I'll rename the channels to Paper Fiber Color, Roughness, and Normal. Next, I want to make the outside of the Hongbao red. To do this, I'll create a new solid color layer and use a mask to control where it appears. Instead of creating the mask afterward, I can choose solid color with image mask directly. I'll name it base red. Leave the mask color set to black. Set the resolution to 4K and press OK. Now the solid color layer is automatically created together with a black image mask. I'll hover over the middle red color in my palette and press Ctrl+C to copy it. Then I'll hover over the layer color picker and press Ctrl+V to paste it. The red color is not visible yet because the black mask makes the entire layer transparent. You can click the checkbox next to the mask to temporarily enable or disable it. To reveal the red color only on the outside surfaces, we need to paint those parts of the mask white. To quickly fill areas, we can use the Fill tool. Remember that holding Ctrl uses the secondary color instead. However, I don't want to mask the entire Hongbao, only the outer surfaces. For this, we can use Paint Mask. First, switch to Edit mode. Select one face from each UV island on the inside of the Hongbao, then press Ctrl+L to select linked geometry. In the pop-up menu, make sure Delimit is set to Seam so the selection stays limited by the UV islands. Then press Ctrl+I to invert the selection and select all the outer faces and edges instead. Switch back to Texture Paint mode and enable Paint Mask. Now, when using the Fill tool, only the selected faces can be painted. When you're finished, disable Paint Mask again. You can also rotate the studio lighting in the Viewport Shading menu to see the back surfaces more clearly in Material Preview. If you rotate around the model, you can still see the roughness variation coming from the paper layer underneath. However, the red color itself looks very flat, so I want to add some variation. Sometimes you may want to preserve the brightness and detail from the layers below. In those cases, you can change the blend mode from mix to color. This keeps the brightness variation from the paper texture while tinting it with the new layer color. However, for this material, I want the red surface to feel smoother and cleaner rather than looking like rough recycled paper, so I'll switch the blend mode back to mix. To add subtle color variation, I could create another solid color layer from scratch, but instead I'll duplicate the existing one. Open the drop-down menu next to the Layers window and choose Duplicate Layer. This also keeps the existing mask, so we don't have to recreate it again. I'll use this layer for dark red variation, so I'll copy and paste the dark red color into the color picker. Then I'll rename the layer Dark Red. The mask name updates automatically together with the layer name. Right now the dark red covers the entire surface evenly, but I want to break it up and blend it more naturally with the base color underneath. To do that, go to the mask section and add a generated noise mask. This breaks up the original black and white mask using procedural noise. The noise itself is not visible in the image editor because it doesn't use an image texture. To preview it properly, first make sure the correct channel is selected. Then select the noise mask as the active mask. Finally, set the layer preview mode type to active mask custom data and enable preview mode. By default, the noise mask uses RGB values. This is equivalent to using the color output from a noise texture node in the shader editor. While that works, I personally prefer using clean grayscale values instead. So I'll change the input type from noise color to noise factor. This makes the mask easier to understand visually. Black becomes transparent and reveals the layer underneath, while white keeps the dark red visible. Next, we can adjust the shape of the noise. I'll reduce the detail and roughness values by about half to create larger and softer blotches. Finally, we can increase the contrast between the visible and transparent areas. Click the cogwheel icon next to the noise mask and add a color ramp. Then move the sliders closer together to increase the contrast between black and white. Exit preview mode to see the final result on the model. Next, I want to add some light red color variation. This becomes much easier now that we already have a variation layer set up. I'll duplicate the dark red layer, then I'll copy and paste the light red color into the color picker. Turn on preview mode. Right now the noise pattern is positioned exactly the same as the duplicate layer underneath. To break up the repetition, open the vector drop-down of the noise texture, then offset the noise on the X and Y axes. Exit preview mode to see the result on the model. Since lighter color variation is usually more noticeable to the eye, I'll reduce its intensity slightly. To do that, open the color ramp of the noise texture and select the white slider. Lowering its value pushes it closer to black, which makes the effect more transparent. Finally, I'll rename the layer to light red. There's also another simpler way to add color variation without creating additional layers. I'll show that later in the tutorial, but this method is useful when you also want to control additional channels inside those same variation areas. Next, folded paper usually develops creases where it bends. To create that effect, I'm going to use bump information. Click the plus icon to add a new layer. You can use an image layer if you want to manually paint the creases yourself. This time, set the channel to normal. Leave the type set to bump map and choose a texture resolution. Then enable 32-bit float. This is important for normal and bump information because these channels depend on very small value differences. Using 32-bit allows smoother gradients and higher precision. This creates a transparent texture with only the normal channel enabled. You can use the arrow icon to move the layer to the top of the layer stack. Switch to the brush tool. Now we can paint white for raised bump and black for indented bump. In the stroke menu, you can change the stroke method to line. Then click and drag to draw straight lines. In the fall-off menu, you can control how sharp or soft the brush edges are. There's a lot you can do with these settings. For example, increasing the stroke spacing and changing the fall-off to sphere can create evenly spaced circular patterns. If you paint with white using those settings, you can quickly create rivet-like bumps often seen on metal surfaces. And if your bump details look too sharp or pointy, simply reduce the bump height. If you want the bump details to also have a different color, simply enable the color channel. Then switch the source to custom color and choose a color value. If you enable preview mode, you'll notice that the mask fades toward the edges. That's why the red layer underneath starts to show through. If you want sharper edges in the color channel, add a color ramp. Then disable the color channel so the adjustment only affects the alpha. Move the white slider toward the left to tighten and sharpen the mask. You can also enable the metallic channel and set the source to custom value to make the rivets fully metallic. The roughness channel can be controlled the same way. You can either use a custom value or drive it using textures such as a procedural noise. Obviously, I don't want metallic rivets on my home bow, but this gives you an idea of how flexible the layer system is. Next, I'll show how I want to create the paper creases, but instead of using an image layer, I prefer a slightly different workflow. I'll delete this layer by pressing the minus icon, then I'll add a new solid color layer with an image mask. Set the channel to normal, leave the type set to bump map, keep the layer color white, and set the mask color to black. Since we're working with bump information, enable 32-bit float again, then choose the texture resolution and press OK. Now we have a black mask where we can paint white to reveal the bump effect. I prefer this approach because it gives cleaner control while avoiding unnecessary texture information. To draw the creases, I'll set the stroke method to line and the fall off to sharp. Then I'll reduce the brush size, zoom out, and draw white lines from corner to corner. However, I want the creases to appear on both sides of the home bow at the same time, so I'll undo the stroke. Open the options drop-down and disable both occlude and backface culling. Now when I paint on one side, the stroke also passes through to the opposite side. Then I'll draw the remaining crease lines between the other corners. I recommend avoiding viewport zoom while drawing because the stroke size changes depending on the zoom level. Instead, hold Shift middle mouse button to pan the view. When the dashed preview line appears smooth without jagged stepping, the stroke is perfectly straight. Once finished, I'll zoom in and check the placement. I think this looks pretty good. The bump effect is a little too strong, so I'll lower the bump height slightly. The center of the strokes also looks slightly jagged because the brush size was fairly small. To smooth that out, I'll switch to the blur tool and set the stroke method back to line. Then I'll reduce the strength by about half and blur each crease once. Now the creases look much smoother. Looking at the mask image texture, some of the strokes have spilled outside the borders of the home bow. To clean that up, switch the image editor from View to Paint mode, then select the brush tool and paint over those areas using black. Switch back to View mode and the spill is gone. Next, the creases still look a bit too uniform, so I want to add some imperfections to them. In my paper folder, there's also an additional displacement texture included in the same texture set. I can use this to add subtle paper fiber detail to the creases. Press the plus icon to add another mask, then choose Open Image as Mask. Then open the displacement texture. The new mask is set to multiply blend mode by default. When black and white masks are multiplied together, black always dominates, so the black areas from the crease mask remain hidden, while the texture detail only affects the visible white areas. However, if we zoom in, the texture breaks at the UV seams. To avoid this, switch the coordinate type from UV to Object. Then scale the texture until it roughly matches the size of the previous UV projection. Now the creases stand out more naturally and remain visible from a distance, while still blending into the paper surface. Finally, I want the creases on the inside of the home bow to be indented instead of raised. So I'll duplicate the crease layer and make the bump height negative. However, the indented bump is now stacking together with the raised bump. So first, I need to remove the raised creases from the inside surfaces. I'll select the crease mask from the original raised layer. Then I'll fill the inside of the home bow with black to hide the raised bump there. But before I can do that, I need to activate the texture mask for the inner faces. Switch to edit mode and press Ctrl L to select all linked faces on the inside. Then switch back to texture paint mode and enable texture mask. I'll also re-enable Occlude and backface culling so I don't accidentally paint through the mesh later. Then use black to fill the masked area. Now the raised bump no longer affects the inside surfaces. Next, we need to remove the indented bump from the outside faces instead. So I'll select the crease mask from the indented layer. Then switch to edit mode and press Ctrl I to invert the selection. Then switch back to texture paint mode and enable texture mask. Then use black to fill the masked area. Next, you might notice a few artifacts where the fill tool missed some small areas. In those spots, select the crease mask for the opposite side and paint black over them using the brush tool. You can also switch the image editor from view to paint mode and paint directly onto the mask texture. Disable overlays temporarily to hide the wireframe and make any remaining white areas easier to spot. You may also notice artifacts like these. These are not caused by the mask itself, but by the bump information. To clean them up, select the outer crease mask and use the smear tool. Then I'll repeat the same cleanup on the backside. You can rotate the studio lighting to inspect the surface more clearly. While checking the inside of the home bow more closely, I also noticed that the paper texture breaks at the UV seams. To fix this, go to the paper fiber layer and switch the coordinates from UV to object. Then scale the texture until it roughly matches the previous projection. Now the seams are no longer visible. This is what I mentioned during the UV unwrapping process. Even if a seam runs through the middle of a surface, there are still ways to apply textures without visible breaks. There's one more thing I want to mention before moving on. Right now the bump source is set to layer color. Since the layer color is white, the bump behaves correctly. However, if the layer color changes later, it will also affect the bump intensity. To avoid that, switch the bump source from layer color to custom color, then set the color to pure white. Now the bump becomes independent from the layer color, which helps avoid accidental changes later. I'll switch the outer crease layer to custom color as well. Now the flap creases are finished, but I just realized that I forgot to add a crease around the notch. I'll select the crease mask on each layer and paint those details in separately. Next, I'll clean up any wide areas that spilled across the edges. However, this reveals an issue with the UV layout. I'll enable overlays again so we can see the wireframe more clearly. The notch borders were unwrapped very close to the edges of the hole. Because of that, paint starts bleeding onto the neighboring border faces. You could try manually cleaning it up, but it usually won't be completely perfect. In some situations, this kind of UV placement can actually be useful if you want to paint continuous detail across neighboring borders. But for normal and bump information around sharp edges, it can create problems like this. So this is something worth keeping in mind when planning your UV layout. It's not a major issue, but it's something we can fix. If we go back to the UV editing workspace, I can separate the notch borders into their own UV islands. First, press A to select everything, then press P to pin the UVs. This pins all UV vertices in place. Then select the edges at the bottom of the notch borders. Live Unwrap is still enabled, so marking seams will automatically unwrap the mesh again. However, because the UVs are pinned, the existing islands will stay in place. This helps preserve the scale and proportions of the current UV layout. Then move those islands into an empty area of the UV map. You might notice that some vertices are still sticking together. If that happens, go to Sticky Selection mode and set it to Disabled. Once the notch borders have their own UV space, I'll switch back to the texture paint workspace. The inside already looks correct because the paper fiber texture uses object coordinates instead of UVs. But the outside still needs to be fixed. I'll select the mask from the base color layer. Then switch to the Fill tool. Go to Edit mode. Select the notch islands. Enable Paint Mask. And fill them with white. I'll repeat the same process for the dark and light red variation masks. If you look closely, you might notice that the color variation still breaks at the seams. It's easier to spot in some other areas, such as down here. That's because the procedural noise masks are still using UV coordinates. If we select one of the noise masks and enable preview mode, you can clearly see the seams in the noise pattern. To fix that, switch the vector coordinates from UV to object. Then scale the noise until it roughly matches the previous appearance. I'll do the same for the light red variation layer. Now the visible color seams are gone. Next, since the UV layout is fixed, let's redraw the notch creases. I'll enable Paint Mask again so the strokes don't spill across the borders. At first, my paint mask started behaving strangely. To fix that, I went to the View tab in the M panel and lowered the Clip End value. Now I'll redraw the crease. This time there's no paint bleeding across the UV borders. Next I'll mask the opposite side and draw the indented crease there as well. Then I'll blur both sides using the blur tool. Finally, I'll clean up any remaining white areas left behind after blurring. Now the base paper material is finished. That was a bit of a detour, but I think showing these kind of problems and fixes is useful for understanding real production workflows. Next I want to add some decorative details. I'll start with the floral pattern that I prepared earlier as an alpha texture in my project folder. I want to stamp it into the paper using bump information again, so I'll follow the same workflow as for the paper creases. Add a new solid color layer with an image mask. Set the channel to normal, leave the type set to bump map, and keep the mask color black. Enable 32-bit float, choose the texture resolution and press OK. Next we'll use the floral alpha texture as a brush mask. Go to the texture properties. Select brush mask from the drop-down. Click new, then click open. I'll find the floral alpha texture, select it and click open again. Now the texture is loaded as a brush mask. You can find its settings in the tool properties panel. Right now the entire texture is painted in a single brush stroke. To position it manually, change the mask mapping mode to Stencil. Now we can freely place and transform the alpha before painting. Hold Alt-right mouse button to move the stencil. Hold Shift-Alt-right mouse button to scale it. Hold Ctrl-Alt-right mouse button to rotate it. You can also reset the stencil transforms using the Reset Transform button. By default, Blender squeezes stencil textures into a square shape. My floral alpha is already square, so this is fine here. But if your image uses a different aspect ratio, enable Image Aspect to preserve the original proportions. Next I'll disable Occlude and backface culling again, because I want to paint on both sides at the same time. Then I'll switch to edit mode and select the UV islands where I want the pattern to appear. Press Ctrl numpad minus once to shrink the selection slightly. This helps avoid overlapping the nearby crease details. Then I'll enable Paint Mask. Position the stencil and paint using white. After that, I'll move downward and paint the bottom section using the opposite side of the stencil. Once finished, click the cross icon to remove the stencil and disable Paint Mask again. Then check if the placement looks correct. For the outside surfaces, I want the bump to be indented. I'll reduce the bump height slightly to make it feel more natural. On the inside, I want the bump to be raised instead, so the paper looks pressed outward. I'll use the same workflow as before with the crease layers. Duplicate the layer. Invert the bump height. Then remove the inside surfaces from the outer mask. Don't forget to re-enable Occlude and backface culling first, otherwise the paint will affect both sides at once. Then remove the outside surfaces from the inner mask. I'll rename the layers to Floral Outer and Floral Inner. I also want the outer pattern to have a slightly different color, so I'll enable the color channel on the outer layer. The source is currently set to Layer Color by default. I'll switch it to Custom Color and paste in the dark red color. Now the outer floral pattern uses dark red, while the inside keeps the original paper fiber color. You might be unhappy with the placement of your masks. For example, I wish both of these patterns were positioned a bit further up. In these cases, you don't necessarily need to redraw them. Instead, you can go to the vector drop-down of the active mask, then move them by adjusting the offset values. However, the limitation is that this will move everything drawn on the mask together, so you can't move just one part of the mask separately unless you draw it on a separate mask. I'll move the opposite side up by the same amount. Next, the mask on the inside is looking too sharp. To make it look more like pressed paper, I'll use the blur tool to soften the edges of the mask. I'll do this directly in the image editor. Now the edges look more natural. Another way to stamp details onto your model is by using decals. In my project folder, I also have this seal texture. I want to place it underneath the notch. Right-click the texture and open the Ucupaint menu. Here we have 3 different ways to use the image as decal. The first option is Open Image as Decal Layer. I'll select it. Set the channel to normal with the type set to bump map, then press OK. This creates a new layer together with a decal empty object that is parented to the model. You can switch to object mode and select the empty manually, or press Select Decal Object in the layer vector settings to select it automatically. Then you can freely move, rotate and scale the decal into position. If we select the model again and look at the layer source, it's currently set directly to the image texture. This means the image values themselves are driving the material channels. For bump information, this means bright values push outward, while dark values push inward. That's why these dark borders appear around the decal. Open the bump channel dropdown and look at the mid-level value. The mid-level controls which grayscale value is treated as neutral or flat. Black equals 0, white equals 1, and middle gray equals 0.5. If I lower the mid-level to 0, black becomes the neutral value instead. Now the dark borders disappear and only the brighter parts of the image create raised bump detail. This is a very fast way to place decals onto a model. However, using the image directly as the layer source can also be limiting. The image is not behaving like a traditional mask where black is transparent and white reveals the effect. Instead, the image values directly control the channel behavior itself. Because of that, custom values also don't behave as expected. There's no separate mask controlling the visibility, so the effect is applied uniformly across the entire layer setup. That's why I personally prefer working with masks instead. I'll switch the layer source back to solid color and set it to white. This matches the workflow used for the earlier bump layers. Now let's look at the second decal option, Open Image as Decal Mask. Press OK. This time, the image is added as a decal mask instead. A new decal empty is also created and parented to the model. However, I don't actually need a second empty object. So instead of repositioning it again, I'll remove the newly assigned decal object from the mask by pressing the cross icon. Then I'll select the previous decal empty as the decal object instead. Finally, I'll delete the extra empty that was created automatically. Now the image behaves like a proper mask instead. This means we can control color, metallic, roughness, and bump only inside the visible masked areas, while still being able to freely move the decal using the empty object. So using a decal mask gives much more flexibility compared to using the image directly as the layer source. Which brings us to the third decal option, Open Image as Decal Mask for New Layer. This automatically creates a new layer with the decal mask already set up. I'll set the channel to normal and press OK. This creates a new solid color layer with the image assigned as a decal mask in a single step. All that's left is positioning the decal empty, but since I already have another decal empty facing the front, I'll just reuse that one instead. Then I'll delete the newly created empty. I'll also delete the previous layer since this setup is identical. Next, I want the decal positioned exactly in the center underneath the notch. I could position it manually by eye, but I want to be as precise as possible. Select the model. In the vector settings, the Set Position to Cursor button lets you snap the decal empty to the 3D cursor. However, cursor to selection does not update correctly with the armature modifier deformation. One workaround is to temporarily apply the armature modifier, then place the cursor using the Apply Deformation, and undo afterward to restore the modifier. Now we can snap the decal empty to the cursor position using the button. However, this also resets the decal rotation. Another approach is to switch the snapping mode to vertex. Then hold Ctrl to activate the vertex snapping and move the decal empty to vertex snap it directly onto the mesh. After that, I'll scale it down slightly. Next, I'll select the model, make the bump height negative and lower the intensity slightly. Because the mesh is fairly thin, the decal projection already affects the opposite side as well. You can actually leave it like this if you want the same decal to appear on both sides. But similar to the floral pattern earlier, I want the inside bump to be raised instead. One solution would be masking the decal separately on each side. However, there's an easier approach. If you only want the decal to affect one side, you can reduce the decal distance. Then for the opposite side, duplicate the layer and set the bump height back to positive. After that, rotate the duplicated decal empty and vertex snap it onto the other side. You could also parent the second decal empty to the first one, so both move together. This avoids needing additional masks entirely. Like before, I want the seal on the inside to look slightly softer, so I'll select the seal mask on the inner layer and blur it slightly. However, decals are projection based, so the projected image itself is not directly paintable like a normal image mask. There is a blur option in the decal vector settings, but personally I don't like the noise artifacts it creates in cycles, so I'm not going to use it here. Instead, there are two cleaner alternatives. One option is creating a second version of the alpha texture that is already blurred externally. The other option is replacing the inside decal with a stencil painted mask like we used earlier. I'll just stencil paint a new mask instead. First I'll delete the decal mask from the inner layer. Then I'll create a new black image mask instead. Switch to texture paint mode and select the brush tool. Then load the seal texture as the brush mask again. And set the mask mapping to stencil. I'll temporarily increase the decal distance of the outer layer so the decal becomes visible from this side as well. This makes it easier to align the stencil precisely with the existing bump detail. However, the design should actually appear mirrored on the inside because it's pressed through the paper. So I'll change the scale of the stencil from 1 on the x-axis to -1. Then I can align the stencil to the bump and paint the mask using white. I also had to remember to switch back to the inner layer first. Once finished, I'll reduce the decal distance of the outer layer again. Now we can return to the inner layer and blur the mask slightly. The downside of using a painted mask instead of a decal is that it's no longer projection based, so we lose the ability to reposition it afterward like a decal object. But depending on the situation, this workflow can still be more flexible. Finally, I'll switch back to the outer layer, enable the color channel, and change the source to custom color. Then switch back to texture paint mode, select the brush tool, and remove the stencil. I'll copy the dark red color from my palette and paste it into the color picker. Then I'll rename the first layer to Seal Outer and the second layer Seal Inner. And with that, the seal details are finished. So now you've seen both decal-based and stencil-painted workflows, along with the pros and cons of each. I'll go ahead and create some of the remaining decorative details I prepared. Let me quickly bring you up to speed. I replaced the original sealed decal mask with a stencil painted version. Using a painted mask with UV coordinates makes it easier to edit, reuse, and layer additional effects later. Next, I used these coin alpha textures to create 3 additional layers. First, I used the thicker alpha to create an indented bump on the outside. Second, I used the thinner alpha to create a raised bump inside it. Finally, I used the thicker alpha again to create a raised bump on the inside, which I then blurred slightly. I repeated the same process using these fortune alpha textures. First, an indented bump on the outside. Second, a raised bump inside it. And finally, a raised and blurred bump on the inside. I'm still using stencil painting here, which we already covered earlier, so there's nothing fundamentally new happening in this setup. Next, I want the raised fortune detail on the inside to be gold. I could simply enable the color channel, switch the source to custom color, then paste in the base gold color from my palette. However, the color also fades toward the edges together with the bump. To fix that, we could try adding a color ramp to the color channel, but adjusting the sliders doesn't really help here. That's because the fading is actually coming from the blurred edges of the image mask itself. We could also add a color ramp directly to the mask. However, that would also affect the bump shape, which I want to keep unchanged. So instead, I'll remove those modifiers, disable the color channel, and duplicate the layer. I'll rename the duplicate layer gold and build the gold material separately on that layer instead. I'll enable the color channel and disable the normal channel. Now we can safely add a color ramp to the image mask without affecting the bump shape. Then I'll move the white slider toward the left to remove the soft shading around the edges. Next, I want the gold to look more like hot pressed foil. First, I'll enable the metallic channel, switch it to custom value, and make it fully metallic. Then I'll use roughness and normal textures from a foil material I downloaded from Ambient CG. To add them, activate the channels. Open the source data settings, switch the source to custom data, and open the texture image. I'll load the foil roughness texture into the roughness channel, and the foil normal texture into the normal channel. Next, I'll increase the UV tiling in the vector settings. This makes the foil detail appear smaller and more believable at this scale. The normal effect is a little too strong right now, so I'll reduce the normal strength slightly. Finally, I want to adjust the foil roughness a bit. I'll add a color ramp to the roughness channel. First, increase the alpha of the black slider to 1, otherwise the darker areas of the roughness map become transparent and stop affecting the material. Then I'll increase the brightness of the black slider slightly so the darker areas are not completely glossy. Finally, I'll move the white slider left and the black slider slightly right to increase the roughness contrast. Next, I want the inner coin detail to use the same gold material. Instead of rebuilding the setup from scratch, I can duplicate the existing fortune gold layer. I'll rename it Coin Gold. Right now, the duplicated layer still uses the fortune mask, so I'll add a new mask. Choose Open Existing Image, and select the coin mask instead. Then I'll remove the old fortune mask. Now the gold material is applied only to the coin detail, without needing to recreate the entire material setup. Next, I'll add a color ramp to the coin mask and increase the edge contrast. Then I'll use the arrow icon to move the layer downward so it stays grouped together with the coin layers. Next, let me show you another way to add color variation. Earlier, we created separate layers for the red variation. That approach is useful when you also want to control other channels, such as roughness or bump, inside those same variation areas. I may still do that later, but if you only want color variation, there's a simpler method. Set the color channel source to custom data, then choose Noise. Next, add a color ramp modifier. Press the plus icon to create additional color sliders. Then I can copy colors from my palette and paste them directly into the color ramp sliders. Now the noise generates color variation automatically across the surface, and if needed, I can adjust the slider positions to control the contrast between the colors. I'll use the same workflow for the fortune gold as well. And of course, you can further customize the noise pattern itself by adjusting the noise settings. Although in my case, I forgot to tweak them here. There's another thing I want to show you with the foil bump setup. Right now, the blend mode of the foil normal texture is set to mix. This means the foil normal completely replaces the underlying paper fiber normal detail. However, when foil is hot pressed onto paper, some of the paper texture usually still shows through underneath. To recreate that effect, switch the blend mode from mix to add. Now the foil normal combines with the underlying paper surface instead of replacing it entirely. I'll set the normal blend mode in the coin gold layer to add as well. Next, I want to reduce how much paper fiber appears inside the gold areas. Go down to the paper fiber layer, add a new mask, choose Add Existing Mask, and select the mask for the area you want to isolate. Now the paper fiber only affects the masked region. Invert the mask so the paper fiber affects everything outside the gold instead. Then lower the mask mix strength until you get the amount of paper texture you want showing through. And this is one of the biggest advantages of working with masks. I can control exactly where different material details appear across the hongbao. Now the main design of the hongbao is finished. The last thing I want to show is how to add subtle surface imperfections. For example, we can create edge wear, add a new solid color layer, then add a generated noise mask. Set the coordinates to object so the noise doesn't break across UV seams. Increase the scale of the noise. Then add a color ramp modifier and adjust the sliders to control the contrast. I'll also increase the noise detail and roughness slightly. Now we have a basic wear pattern. To limit it only to the edges, add another mask and choose Edge Detect. This generates a mask based on the edges of the geometry. Temporarily disable the noise mask so the edge mask is easier to see. You can lower the edge radius to tighten the mask around the edges. Right now, the edge detection only considers the actual mesh geometry. It doesn't take the bump and normal information into account. But if you enable Use Previous Normal, the generated bump details also influence the edge detection. Then I can enable the noise mask again to break up the edges and make the wear look more natural. Now you can decide what material properties the edge wear should affect. For example, I can enable the color channel and sample the paper fiber color texture. Now it looks like the red surface is worn away, revealing the brown paper underneath. I'll also change the vector settings so that they match the paper fiber layer. You can also adjust the roughness and bump to make the worn areas feel more damaged. However, if I enable the bump channel, the model suddenly turns pink. This happens because I exceeded Eevee's texture limit, and Material Preview uses Eevee internally. If we switch to Cycle's rendered preview, the textures still display correctly. So I'll reduce the bump height slightly and make it negative instead. You can also enable roughness and make the worn areas rougher than the surrounding paper. If you want to avoid the pink material issue in Material Preview, it helps to keep the number of active layers as low as possible. For example, I can delete the separate dark and light red variation layers. Then I can move the color variation directly into the base red layer instead. I'll switch the color channel source to noise. Then set the vector coordinates to objects so the noise does not break across UV seams. Right now the material recalculates very slowly because the edge wear layer is fairly expensive, so I'll temporarily disable it while adjusting the noise. Then I'll adjust the noise settings, add a color ramp, and create an additional slider. Next I'll copy the colors from my palette into the color ramp. Finally, I'll increase the contrast by moving the sliders closer together. Now we can continue editing the edge wear without the material turning pink. I also don't want the wear effect to appear on the gold details. To exclude those areas, I'll add the existing gold mask as another mask on the edge wear layer. Then I'll set the blend mode to subtract. This removes the white parts of the gold mask from the wear calculation. I'll repeat the same setup for the coin gold areas as well. One thing I haven't covered much yet is manually painting material properties by hand. Create a new solid color layer with a black image mask. And if you plan to use bump or normal information, enable 32-bit float. Now you can use brushes such as the soft brush to manually paint the mask. Lowering the brush strength helps create softer and more uneven detail. You can also experiment with tools like the smear tool to make the result feel more natural. Then you can assign a custom brownish color to create dirt or grime. Inside the texture properties, you can also assign textures directly to the brush itself. You can download alpha brush textures online or use Blender's built-in procedural textures, such as clouds. This helps break up the brush strokes and creates more natural-looking variation. There's also a 3D asset library called BlenderKit. You can visit BlenderKit and install the BlenderKit add-on. After installing it, you can browse brush textures directly from the BlenderKit toolbar. Some assets require a subscription, but many textures, such as this grunge texture, are free. If I click the texture and then paint on the model, the brush texture loads automatically into the brush settings. Using textured brushes like this can create much more natural surface detail. Usually, the best results come from building up the effect gradually over multiple passes instead of painting everything in one stroke. You can use this workflow for painting color variation, dirt, metallic wear, roughness changes, or bump details. And if you have a drawing tablet with pen pressure support, this workflow becomes even more powerful. I only created this layer as a quick demonstration, so I'll delete it afterward. Another way to add surface imperfections is by using Ambient Occlusion. Create a new solid color layer. Then add an Ambient Occlusion mask. This creates a mask by calculating how close different parts of the geometry are to each other. Next, add a color ramp modifier to control where the effect appears. Invert the color ramp so the material properties appear inside the occluded areas instead. As a result, areas where dirt and grime would naturally collect become masked automatically. Then switch the layer color to a custom dirt color. Finally, add a noise texture together with a color ramp to break up the effect and make it look more natural. Ambient occlusion is also commonly baked into its own texture map. To do that, press the plus icon next to the Channels window and add an Ambient Occlusion channel. Then press the plus icon next to the Layers window and create an Ambient Occlusion layer. By default, it is set to affect the color channel, but you can switch it to the dedicated AO channel instead. Unlike the previous setup, where the AO was used as a mask, this version is intended to darken areas where geometry is close together. It recreates the soft shadowing we naturally see in tight crevices and intersections. If you preview the Ambient Occlusion channel, the effect becomes easier to see. You can also add a color ramp directly to the channel to control the intensity and contrast. Then the AO can be baked into its own separate texture map for export if needed. Finally, press the plus icon next to the Channels window and add an Alpha channel. This allows opacity information to be baked into a separate texture map as well. Create a new solid color layer with a black mask and switch the layer channel to Alpha. I'll set the Alpha channel source to custom value and lower it to 0 so the layer becomes fully transparent. Now I can paint a mask wherever I want the surface to become transparent. If you disable Occlude and backface culling, you can paint all the way through the mesh. Then the opacity information can also be baked into its own texture map separately, but I'm not actually going to use these extra layers in this project, so I'll delete them again. I'll also remove the AO and Alpha channels afterward. Now we've finally reached the last step, which is baking the material into texture maps. Before baking, make sure there aren't any objects or modifiers visible that could interfere with the result. For example, I still have these mask modifiers enabled in renders, so I'll disable them first. Next to the name of the Ucupaint node setup, there's a cogwheel icon. Click it, then choose Bake All Channels. I'm baking at 4K resolution to preserve as much detail as possible. Samples are set to 32, which usually gives clean results without increasing the bake time too much. AA level 2 slightly smooths the edges. A 16 pixel margin helps prevent visible seams. I enable 32-bit for the normal channel to preserve smoother gradients and more precise detail. GPU compute speeds up the baking process. FXAA is disabled because it can blur the texture maps. These settings work well in most situations, but depending on your project, you may want to lower the resolution or adjust some of the bake settings. Once everything is ready, press OK. The baking process may take a few minutes depending on your hardware and texture resolution. After the bake finishes, you can click the different channels to preview the generated texture maps. The baked image files are also listed below. The baked normal channel includes 2 additional generated textures. You can cycle through them by repeatedly clicking the normal channel. One is the regular normal map without bump information. The other is a grayscale displacement map. Right now, the baked color map has a white background. You can press Use Bake to switch back to previewing the original layer channels again. The white background comes from the default base color of the color channel. For roughness and metallic, the default background values are usually fine. But for the color channel, I'd prefer the empty background areas to be red instead. That way, if there are tiny seams or unpainted areas, they blend together more naturally with the material. So I'll switch back to the layer channels. Then I'll copy the base red color from my palette and paste it into the color channel background color. Now when we rebake the textures, the white background areas will become red instead. Next, take some time to inspect the baked result and look for possible issues. For example, I'm getting some strong bump artifacts in the center of certain faces. This is caused by the Edge Detect mask. If I select the mask and preview the normal channel, you can see that the paper fiber normal detail is also being included in the edge detection. I could reduce the edge detect radius even further, but then the actual outer edge wear almost disappears. Another option would be disabling Use Previous Normal entirely. However, then I lose the wear effect in areas created only by bump and normal information rather than actual geometry. You could solve this by creating separate edge detect layers for different parts of the material. But in my case, I'll just remove the edge wear layer completely and keep this version of the material cleaner. Next, I noticed the gold material creating a slight yellow halo around the bump edges. To tighten that up, I'll move the black slider further inward to sharpen the mask. So far, we've mostly been using color ramps for these adjustments, but there's another modifier I want to show you as well. Using the raised fortune bump as an example, we can also use the curve modifier inside mask modifiers. The lower left represents black values, while the upper right represents white values. By reshaping the curve, you can control how different value ranges behave inside the mask. This can create more interesting bump transitions and sharper or softer shapes. Now I'll switch back to the baked channels and continue checking the rest of the material. The coin gold looks fine. Everything else looks good as well. It's also a good idea to inspect the material in rendered preview, especially under different lighting setups or HDRIs. Sometimes problems become visible there that you might not notice in material preview. For example, the roughness on the gold might still be a bit too strong, but I'll leave it like that for now. Once you make additional adjustments to the layers, you can simply press Rebake to generate updated texture maps again. I'll rebake using the same settings as before and press OK. Once the rebake finishes, I'll check the results one more time. The bump artifacts are now gone. The gold edges also look much cleaner. And the color map now uses a red background instead of white. Once you're happy with the baked textures, you can save each texture map individually, or press Save as All to export all texture maps at once into a folder. Then you can use those baked textures just like any other PBR texture set. The best thing about Ucupaint is that you can easily go back and adjust your materials. Before the final render, I added another black mask to the outer crease layer. Then I used an alpha to stencil paint some more random creases and folds. Next, I loaded another surface imperfection texture onto a new layer. Then I masked it to only affect the roughness and bump of the paper material on the inside. I also added another layer with an additional paper fiber bump texture. I reduced the influence of the bump on the gold parts by half using masks. I duplicated the layer to use the same texture for some roughness variation. I removed that roughness from the metal parts entirely. Then I added another layer with a wrinkled paper texture. The model turned pink, so I continued working in rendered preview. I also added a layer of subtle dents and unevenness across the whole model. You can get even better results by continuing to layer and texture paint your materials. But this is good enough for this tutorial. The key to achieving more realism is to keep layering details. And that's it for this tutorial. Ucupaint is an incredibly powerful add-on and there's still a lot more you can do with it. But hopefully this gave you a solid workflow for taking a model from UV unwrapping all the way to a fully textured and baked material. This tutorial took a long time to make, so if it helped you, a like and subscribe would really mean a lot. And if you want to understand texture maps and material channels more deeply, feel free to check out my PBR tutorials as well. Thanks for watching, and I'll see you in the next one.